take a look at the nature of roots. Now, nature of roots is just a fancy way of saying the characteristics of x-intercepts, or how we would describe our x-intercepts. So here you have a quadratic equation and your quadratic formula. And the thing that is underneath the root sign is what we're going to use to describe our x-intercepts, or to find out the characteristics of those intercepts. That which is underneath the root sign is called the discriminant, otherwise known as delta. Okay, let's see how our roots are described. When you have delta being greater than 0, your function will look something like this, or like that, and you can see that your x-intercepts will be present, and there will be 2 of them, which means that underneath this root sign you have had a positive value. Your roots are real, as can be seen. They are unequal, and where your delta is a perfect square, like 4 or 9, there'll be rational roots. And where delta is not a perfect square, your roots will be described as irrational. When delta is equal to 0, your function will look something like this. And you can see that there is only one x-intercept. All right. Thus, when you are solving here, your root is going to be equal to 0. And you'll notice that this formula will be quite familiar to you. It is the formula of your turning point, the x value thereof. As an interesting aside. Right, when your delta is equal to 0, your roots will be real and equal. When delta is less than 0, this is what your function will look like. And you can see that it is not intercepting with the x-axis. This happens where you have a negative under your square root sign in your quadratic formula, and as we know, you cannot have a negative square root. Therefore, the roots are non-real. Okay, let's do a practical example using nature of roots. And this example, we're going to be finding the values of k for which this equation has equal roots. The equation being x squared minus kx plus k over 2 is equal to negative 2. And first, I'm going to equate all of this to 0. So x squared minus kx plus k over 2 plus 2 is equal to 0. And they're asking us the values for which this equation has equal roots. And we know that where we have equal roots, delta is going to be equal to 0. Delta, as we heard earlier, is equal to b squared minus 4ac. Therefore, in this equation, 0 has to be made equal to negative k squared, because our b value is the value before our single x value, the coefficient of x, minus 4a, which is the coefficient of x squared, in this instance being 1, and c. So c is the final value over here, which is k over 2 plus 2. And we're going to multiply that in. That must all be made equal to 0. Let's solve that out. 0 is equal to k squared minus 4 multiplied by k over 2 is 4k over 2, and 4 multiplied by 2 would give us negative 8. Therefore, 0 has to be equal to k squared minus 2k minus 8. And we're going to solve for k in the same way that we solve for x, by factorizing. We're going to get a value of k minus 4, k plus 2 is equal to 0. And that is going to give us an answer of k is equal to 4 and k is equal to negative 2. Wonderful. So in this example, in the following, f of x, this function has a turning point at 3, 2. They've asked us for which values of k will f of x is equal to k have real roots. Now my first step is going to equate this to 0. So f of x minus k will be equal to 0. In the existing function, our turning point of our function is 2 units above the x-axis. We want this to either intercept directly with the x-axis at one point or at multiple points, which means that this function needs to be translated to meet this axis. Although any translation that is further than 2 units down would also serve the purpose of giving this function real roots. Therefore, to translate this 2 units down, we need to make this f of x minus 2 is equal to 0. Therefore, the k value will be anything greater than or equal to 2, which will permit this function to either intercept with this axis once or multiple times. I'm going to give you an opportunity to discuss the nature of roots of y is equal to 3x squared minus 9x minus 3, after which you can come back and we'll see how you've done. Awesome. Now that you have had a chance to look at that, let's look at it together. So we have y is equal to 3x squared minus 9x minus 3, and we're discussing the roots. Delta is going to be equal to b squared minus 4ac once more. In this example, delta is going to be equal to negative 9 squared minus 4, 3, negative 3. Therefore, delta is going to be equal to 81 minus plus 36. And that is going to give us a net answer of 117. Therefore, delta is going to be greater than 0. And as per discussed earlier, that means our roots are real, irrational, and unequal.